This is a very frequently asked question in JavaScript interviews. So they will ask what is going to be the output of this code. And this is tricky because, and the interviewer has deliberately put 0 here in the set timeout, and promise is getting resolved immediately. So it looks like the sequence will be a start, then callback of set timeout will be executed, printing this, then callback of promise will get executed, printing this, and finally end will get printed. But that's not the output. Let's see the output. Okay, so the output is something like this. So here a start got printed, after that end got printed, and then somehow promise resolved got printed. So promise callback, okay, got executed, the third. So promise resolved got printed, and then at last set timeout callback got executed. So now the question is, why this sequence? Why it executed the code in this particular sequence? So answer of this question will become very easy if we understand some concepts of JavaScript, like what is call stack, what is callback queue, what is event loop. We will see what is a blocking operation, non-blocking operation. Once we understand this concept, we will come back to this question again, and we will try to answer this question. And then it will become very logical that, okay, this sequence is correct. Let's see how our JavaScript code gets executed. The JavaScript code gets executed by something called JavaScript runtime engine. So there are different kinds of JavaScript runtime engine. One of them is V8 that is used by Chrome. So whenever we run any JavaScript code inside Chrome, it gets executed by V8 engine. So JavaScript has something called heap and a stack. So heap is where the objects get stored, and a stack is where our function gets executed. So JavaScript is basically a single threaded programming language. It has only one thread. Consider one thread as one person. So 5 threads means 5 people. In other programming languages, like for example, C#, Java, you can create your own thread, additional threads. Okay, you can have 5 threads, 10 threads. You can create new threads. But in JavaScript, there is only one thread. Okay, because it is single threaded programming language. So a thread has something called a stack, where it runs the code. So as I said, one thread means one stack. So JavaScript can execute only one operation at a time because it is single threaded. So this is our code. Okay, let's see how this will get executed by JavaScript engine. Here we have 4 functions: function 1, function 2, function 3, and function 4. When we call function 1, it calls function 2. Function 2 calls function 3 calls function 4, and function 4 does not do anything. So let's see how this code will get executed. Okay, so each time a function is added, a new entry called frame representing that function is added to the top of the call stack. So right now the call stack is empty. Now we are calling function 1. So a new entry called frame, the frame for function 1 will get added to the call stack. Okay. Now the function 1 actually calls function 2. So function 1 is not yet complete because it is calling function 2 internally. So now there will be another frame for function 2 added on top of function 1 in call stack. Now function 2 calls function 3. So the new frame for function 3 will be added on top of function 2 inside call stack. And again, function 3 calls function 4 internally. So a new entry will be added for function 4 in call stack. And when execution of function 4 completes, it is taken off the call stack, leaving only 1, 2, 3. So now 3 will complete, then 2 will complete, then 1 will complete, and finally the call stack will become empty. So the call stack basically grows or shrinks. Okay, here it is growing and now it is shrinking based upon the function being called or completed. Okay, so anything synchronous will be run inside call stack. Okay, anything asynchronous does not run here. Here is the animated view showing how everything works together. So this is our code, okay, that gets executed inside call stack, and how the browser rendering engine behaves. So when there is something to be executed inside the call stack, the browser will not render anything. It will freeze. Okay, it will resume only when it sees that, okay, there is nothing pending in the call stack. So this code, it just calls a method called place order. And when we call place order, a new place order frame will be placed on this call stack. And now this will internally call cook food. When cook food is done, then the cook food frame will be removed from the call stack. And finally, when place order is done, place order frame will be removed from the call stack. And finally, the call stack will become empty. And that's when the renderer will start rendering something on the browser. What will happen if we try to call lots of functions? So with each function, a new frame gets added to the stack. So JavaScript runtime puts a limitation on the size of call stack. Okay. So if we try to breach that, size limitation, JavaScript runtime will throw exception. So let's create a self-calling function. So let's create a function that calls itself. So here is the function that calls itself called sum. Okay, so sum calls itself. Okay, so this will become infinite loop. So let's call this function 1 comma 2. So what will happen here is with each call to sum, a new frame will be added to the call stack, and soon we will reach the boundary of the size of call stack, and JavaScript runtime will throw an exception. Let's see that. Okay, so this is the V8 engine. It gave us an exception saying that the maximum call stack size exceeded. So now we exceeded call stack size. Now let's see the impact of blocking the main thread, okay, in JavaScript. So as we know that JavaScript is a single-threaded programming language. It has only one thread, okay, that will do all your work. It's not a good idea to block that single thread, okay. So if we block that thread, then we will not be able to interact with the browser. We cannot enter anything in the text box. We cannot click a button. We cannot do anything. The browser will freeze for that duration. So this example here, this code, this mimics a restaurant where we place order and then the cook food gets called. And this is the blocking function. It blocks the main thread for 10 seconds. So, and this blocking delay function is nothing but a while loop. And this is my function. So this is doing nothing, going in a while loop for that duration. So this is happening sequentially, but in a blocking way. Each call to place order will freeze, will block our main thread for 10 seconds. Now, right now, here is the text box. We have a text box on the HTML and we can type something, right? No problem. We can type something. But as soon as we execute this code, see what happens. So we are refreshing this. Okay, now try to type anything. Now I'm trying to type something. See, I can't even see the text box here. And the browser is just spinning here. Okay, it means that my browser is unable to take any user input. Okay, so right now after 10 seconds, pasta is ready. After 10 seconds, salad is ready. And then sandwich is ready. I cannot type anything. My main thread is blocked. Now the program is completed. It means the UI thread is now free. And now I can type anything here. So what is the solution? How we can keep our UI free? Okay, so that's where the asynchronous programming comes into picture. So rather than blocking the main thread, we can give this work to somebody else. And that somebody else is the browser that we will see in the next section. Now, this is the non-blocking version of the same code. The only difference is here we are blocking the main thread, but here we are using set timeout. Set timeout is an asynchronous function. So every time the JavaScript engine will see any asynchronous operation, it will not perform this operation himself. Rather, it will give this operation to be performed to the browser, which is the host. So what browser will do is it will just wait for 10 seconds and then execute this particular function. So by giving this particular function to browser to execute, the main thread of the JavaScript is now free to do the next task. Okay, it is not blocked anymore. Because the JavaScript main thread is not blocked, we can interact with the browser. Now let's see this in action. Now let's run this particular code. Let's refresh this page. Okay, it started, finished. Okay, so it has started, it finished. And in the meantime, we can interact with the browser also and see it is not spinning. And finally, we got the result. Pasta is ready, salad is ready, sandwich is ready. So what's happening here? The JavaScript main thread, it comes to line number 15 because this is the first line of execution. And it can execute this because this is not an asynchronous operation. So it printed started here. Perfect. Then what happened? It moved on to the next line, which is line number 16. Here it sees place order function, okay, with pasta as the parameter. So now it called place order, but inside place order is the cook food. It goes to cook food. And all of a sudden he sees that, oh, this line of code I cannot execute because this is asynchronous. So I have to pass this. I have to tell the browser to execute this. Okay, so I can't do this. So he is telling the browser that take this code, run it. Okay, and after you are done, which is after 10 seconds, call this function. This is the callback function kind of. Okay, and this function order completed will be executed by me. Me is main thread, JavaScript main thread. So while browser is executing set timeout, okay, it is waiting for 10 seconds to pass. The main thread, the JavaScript main thread, moved on to line number 17. It does the same thing. It calls place order with salad. Place order with salad. It will call cook food again with salad. And here it will see again the second set timeout. Okay, it will again give the browser this second set timeout with salad. And it will tell that, okay, when your 10 second passes, call this function which I will execute. Okay, then it will move on to line number 18. Again, the same thing will happen. It will give this set timeout to the browser to execute, passing sandwich. And it is telling the browser that, okay, when your 10-second passes, call this function and I will execute this particular function. Okay, so effectively what happened is that these three lines of code, line number 16, line number 17, and line number 18 code did not get executed directly by the JavaScript main thread. So effectively what's happening is that JavaScript main thread is just printing started and finished. And in the background, after 10 seconds, browser will call order completed for pasta, salad, and sandwich because it has to call this three times for different food. And that's why we see this output like this. First started, finished, then pasta is ready, salad is ready, sandwich is ready. So these three are basically printed from here, order completed, because this order completed was called behind the scene from the browser. This is the visual representation of the overall picture. Okay, so what happens is like our code runs in the stack. So all the synchronous tasks are run directly in the stack. Okay, anything that we put here asynchronous, like set timeout, set interval, promises, because they are asynchronous, they are not directly executed by the JavaScript runtime. Rather, they are pushed to the host. Host in this case can be browser or Node.js. Now the browser has multiple APIs, okay, to perform different kinds of tasks. So there are multiple APIs inside the browser that is specifically built to perform certain kind of operation. So depending upon the kind of asynchronous task the JavaScript runtime is pushing to the host, these tasks will be handled by the corresponding API of the browser. And once that task is done, then what it will do, it will push that callback function in something called task or callback queue. So this is like a queue. This is first in, first out. Okay. So whoever will come first will be served first. And then there is something called event loop that picks up the callback function to execute. And we know that functions always execute in a stack. So event loop has only one purpose. It will check a stack. And if the stack is empty, then it will pick one of these tasks. Now, just to visually represent different kinds of tasks, I have made it like a baby, a woman, and a man. Okay, so these babies kind of tasks are highest priority tasks. They are synchronous tasks. This is the way I look at this overall picture. Now, this callback functions can be of two types. It can be of macro task with A and micro task with I. These are the tasks, the callback functions that ultimately needs to be executed by the JavaScript runtime. And between micro task and macro task, it is the micro task with I that takes the precedence. We can think of it as ladies first. So if there is any micro task with I, okay, this will be executed. This will be picked up by the event loop and placed on the stack before any macro task is picked up. This is how the asynchronous and synchronous tasks are executed inside JavaScript runtime. Okay, so there are three kinds of tasks only, either synchronous task or asynchronous task. Now, asynchronous tasks can be of two types, micro task and macro task. Now, promises callback are micro task. Okay, async await micro task. And macro tasks examples are set timeout, set interval, fetch API, or any user interaction events like click event, like button click, a scroll event. So each time event loop runs, it's called a tick. With each tick, event loop will check if the call stack is empty. If it is empty, and if there are some queued up tasks in the task or callback queue, it will pick up based upon the priority. Okay, so that's why, like if we have some, for example, set timeout, so set timeout will go to the macro task queue. And if we have some promise callback, so this will go to the micro task queue here, because micro task priority is higher than macro task priority. This will be picked up, promises will be picked up first to be executed, and then set timeout. So between promise callback and set timeout callback, it is the promise callback that will always be picked up first because its priority is higher than set timeout. Now, this is the animated version of the overall process. So here we have the code, and here we are using set timeout. So obviously, set timeout will not be run by the JavaScript runtime. Rather, it will be pushed to the browser to run. So here we have this JavaScript call stack, and here is the browser web API. Okay, and this is the event loop, and here is the callback queue. So let's refresh this and see what will run where. Now let's back to the question from where we started. So now try to answer this particular question. So what will happen here is this is synchronous call start. So start will be printed first. Then it sees this asynchronous call set timeout, which is a macro task with a. So this is macro. Okay, this is a macro task. And then this is promise is nothing but a micro task. So micro task. Okay, so now these two will not be run by the JavaScript directly. Rather, these two will go to the browser. And sometime in the future, browser will see that, okay, this is the micro task. So it will put this callback on the micro task queue. And because this is micro task with I, so this callback will be put to the micro task queue. Okay. And because micro task has higher priority than macro task, so event loop will pick the callback of the promise, which is this, and put it on the call stack. After this is executed, then event loop will pick this callback of the macro task and put it on the call stack to execute. And that's why we see this kind of output. So now let's run this again. I save it, and now we see this outputs. So I hope this video helped you understand how JavaScript executes synchronous as well as asynchronous tasks. What is an event loop? What is macro task? What is micro task with I? And what is the priority in which these tasks are executed?